Good afternoon, my name is Tyler, and along with Daniel, Tolu, and Ahmed, we will be presenting our software engineering project for this term. First, I would like to go over the purpose and scope of the project. The purpose was to develop a software product with the capabilities of processing student data, reading from given input files, calculating final grades, and generating a formatted output. For scope, we broke this down into in-scope and out-of-scope capabilities. What will be supported is file reading, data processing, and file output, and what will not be supported is real-time processing, graphical user interface, or file input generation. We have some assumptions and limitations for this task. As far as assumptions go, we have the assumption that input files follow a specified format and are comma separated, we have the assumption that student identification number and grades are numeric, and the assumption that courses that reference unmatched identification numbers will be ignored. The limitations for our project is that it will not support large-scale datasets, and that it will only support single system operation with no database integration. The functional requirements for the project include file input, where the program will read two input files named namefile.txt and coursefile.txt. This data will then be processed by matching courses to students by identification number and calculating the final grade. Then we have the file output, where a formatted data file will be printed to outputfile.txt. We have also incorporated error handling to manage missing or malformed input files. The non-functional requirements of the project, we have the requirement of reliability. There will be strict error handling, and the process will not be halted. An error message will be produced. We have performance requirements. This project will handle small to moderate data sets efficiently. As for usability, this will be a command line application with minimal interaction from the user, and it should be quite portable, operating on all major operating system platforms. Using object-oriented principles, this program will also be maintainable.
Hey guys, my name is Ahmed, and as for high-level design, our project uses a component-based architecture to keep things modular and easy to manage. The main components include a file module to handle reading and writing data structures like student.java and course.java built on an abstract person class to organize and store information, a file writing module to sort and save data in the correct format. Next, for detailed design, let's discuss key classes and modules. The file class handles input and output. Read from file reads input files, creates student and course objects, and matches courses to students using linear search. Write to file formats and writes the sorted data to output files. The student and course classes store information and calculate final grades using a weighted formula. For data structures, list students stores student data, list courses holds their course and grade details. A binary search helper ensures the data is sorted before saving. For key algorithms, final grade calculation and course.final grade calculator uses a weighted formula. Linear search and file.read from file matches courses to students with a time complexity of O to the n squared. Binary search in file.binary search helper sorts students with a time complexity of O to the log n. Next are the design diagrams. A class diagram on the left shows the relationship between classes and their main attributes. The sequence diagram on the right illustrates the flow of data, starting with reading inputs, then processing, sorting, and finally outputting results. These diagrams show how all components interact to achieve the project's goals. So as for testing, our testing covered these conditions: properly formatted files, invalid grades, invalid IDs, missing IDs, and missing names. This ensured the program handles both valid and invalid scenarios effectively. And as for tools, the project was implemented using Java, chosen for its modularity and built-in exception handling. We used the VS Code IDE to simplify coding, debugging, and testing.
To go a bit deeper into the detailed design of our program, we first have our person class. This is an abstract class that initializes both the student ID and name for a person object. The class contains two getter methods used to retrieve both student ID and name. Student class extends the person class by creating an array list of courses, passing a course object as the course to the list, and there's also a getter method to receive the list of enrolled courses. Course class represents a course that a student is enrolled in. It contains a course code, the test grades, as well as the final exam grades. There's a getter method to retrieve the course code, as well as a final grade calculator that returns the final grade. File class provides methods for reading and writing student data to and from files. Buffered reader is used to read from the name file and parses the information by setting it to its corresponding variables. It is then used again to read from the course file to create course objects and then adding those course objects to the corresponding students using their student ID. The write to file method creates a list and sorts students using the binary search helper function. It sorts using IDs from least to greatest and then adds them to the list, which will be iterated through when buffer writer is writing output to the file. Binary search helper method finds index to insert students based on their IDs and ensures that the list stays sorted. Offensive programming here emphasizes rigorous input validation. Check valid ID enforces strict format rules for the ID, and grade parsing ensures reliable conversion, preventing unexpected input errors or crashes.
This is a person class. It's an abstract class, and it contains a student ID and a student name, and two methods, one to get the student ID and one to get the student name. This is the student class. It inherits the person class, contains a list of all courses the student is currently enrolled in, and two methods, one to add a course to the list and one to get a list of all the courses. This is the course class. It contains variables for a course code and grades for tests 1 to 3 in the final exam. It contains a getter method to retrieve the course code, and using the formula given has a method to calculate the final grade. This is the file class. It contains a read from file method that reads data from a name file and course file, and it returns it as a list. Then we have a write to file, which writes a list of students and their course information to an output file. And then we have a binary search helper that's a simple binary search, and it helps find the index at which a student should be inserted at. We have the grade parsing helper method that throws an error when an invalid grade is found. Check valid ID helper function that returns false when the student ID is invalid. And then if we look at our name files given a course file and we run our main method, our output file should be sorted with the student ID least to greatest.